Adding fractions. All right, let's say you made 2 pans of brownies and cut them into 8 slices each. So we have 1 of the 8 brownies remaining in this pan. So 1/8 of a pan remains. And here we have 3 of the 8 brownies remaining. So 3 out of the 8 means we have 3/8 of a pan remaining. So to save space in the refrigerator, you want to combine the 2 pans. So you take this 1 brownie and put it over here. So if you add 1/8 of a pan of brownies and 3/8 of a pan of brownies, you can see that you have 4 out of the 8 brownies remaining, or 4/8. And remember, whenever your answer is a fraction, you always want to reduce that fraction. So 4/8 is the same thing as 1/2 of a pan of brownies. So what have we done here? The denominator has stayed the same because in both cases, the pan was cut up into 8 slices. So that did not change. What did change was we added the numerators because we added the number of parts of a pan that were left. So let me summarize what happened here. So when you're adding fractions with the same denominator, you're going to add the numerators. The denominators stay the same, and then reduce if possible. Let's try a few examples. All right, let's try 3/14 and 4/14. And if you want, you can hit the pause button and try it on your own. So you add 3 and 4, which makes 7. And remember that the denominator stays the same. And then because your answer is a fraction, you always want to see if it can be reduced. So in this case it can. 7 is 7 times 1, and 14 is 7 times 2. 7/7 is equal to 1, so the answer is 1/2. All right, let's try another example. 11/24 plus 7/24. Again, you can hit pause and try it on your own. So we add the numerators. 11 and 7 make 18. And the denominators stay the same. And then you always want to check and see if it can be reduced. So we could either do 2 times 19 or 3 times 6, but I'm looking at the denominator and I'm noticing that 6 goes into 24. And it doesn't matter how you start reducing, as long as you keep going. 6/6 is equal to 1. So whenever you reduce, just check and make sure it cannot be reduced again. And 3/4 is your answer. Let's try another one. So let's add 13/24 and 11/24. And again, you can hit pause and try it on your own. So we add the numerators. 13 and 11 make 24. The denominators stay the same. And if the numerator is equal to the denominator, then that is a fraction that is equal to 1 whole. So you're probably wondering, how do we add fractions with different denominators? Well, if the denominators are different, we have to find a common denominator. So what we have to look for is called the least common multiple of all the denominators. So let's write that down. So the least common multiple, and people usually just call it LCM, of 4 and 6 is the smallest number that 4 and 6 divide evenly. So you might think that's 2 because 2 goes into 4 and 2 goes into 6. But 2 is called the greatest common divisor. That's the largest number that goes into 4 and 6. The least common multiple of 4 and 6 is 12 because it's the smallest number that 4 goes into and 6 goes into. I'll show you how we can find it. So remember the prime factorization that we did earlier. So we write the prime factorization of 4, which is 2 times 2. And then the prime factorization of 6. So if we make a little chart, I'm going to call this the 2 column. Only 2's can go in this column. Only 2's can go in this column. So when we break down 6, it's 2 times 3. So I can write the 2 in either of these columns. And then the 3 gets its own column. And then we bring down each unique factor. Two times 2 times 3 is 12. And you can see that that's the smallest number that 4 goes into and 6 goes into. So that's the least common multiple of 4 and 6. Let's do another. Let's find the least common multiple of 14 and 21. So that's the smallest number that 14 goes into evenly and 21 goes into evenly. So we write the prime factorization of 14, which is 2 times 7. Now that I have the factors, I'm going to make a column. So only 2's can go in this column, only 7 can go in this column. What's the prime factorization of 21? Well, that's 7 times 3. So where do you think the 7 goes? That's right, it goes in the 7 column. Where do you think the 3 goes? Right, you can't put it here because that's a 2 column. So we have to give it its own column. And then we bring down each unique factor. 2 times 7 times 3 is 42. So 42 is the smallest number that 14 goes into and 21 goes into. And then there's a little game I like to call the missing factor game. Which is super fun because everyone's a winner. How does it go? Well, you look on the 14 row and you say what number is missing from 14. Well, there's no number here in the 3 column, so 3 is the missing factor. Well, what is 3 times 14? That's 42. So that's how we're going to make our LCM. What's 21 missing? Well, we look, there's a number missing in the 2 column. So 2 is the missing factor. That's how we get 42. All right, let's try another one. All right, let's find the least common multiple of 12 and 18. And if you want to make sure that you do get the smallest number, you want to only use prime numbers in that chart. So we could write 2 times 6 or 3 times 4, but those are not prime numbers. To break it all the way down, you would get 2 times 2 times 3. And we make our columns. That's a 2 column and a 3 column. Just going to throw an extra one there. What goes into 18? Well, I could do 3 times 6 or 2 times 9, but those are not primes. To break it all the way down to primes, we get 2 times 3 times 3, and that other 3 has to be in its own column. So the least common multiple is going to be 2 times 2 times 3 times 3, which is 36. All right, and then let's play the missing factor game. Everyone's a winner. All right, what's 12 missing? Well, there's no number here. What column is that? That's the 3 column. 3 times 12 makes 36. We'll use this later when we're building up fractions. What's 18 missing? Well, there's a missing number here in the 2 column, so that's the missing factor. All right, let's do this example again without prime numbers to show you what can go wrong. All right, let's do it wrong on purpose just to see what happens. So if we just wrote 3 times 4 instead of breaking it all the way down for 12, and then 18 is 3 times 6. We have a 3 column, so we'll fill that in. And we'll put the 6 over here. And then we get 3 times 4 times 6, which is 72. So 72 is a common multiple of 12 and 18, but it's not the least common multiple. So that's too big, and you'll just make more work for yourself. All right, so you're probably ready for a challenge by now. Let's try finding the least common multiple of 30 and 42. So I highly recommend hitting the pause button and trying it on your own. All right, so I'll break down 30. So I could write 5 times 6, but remember 6 is not a prime, so I'm going to keep breaking it down. And it doesn't matter what order you put these primes in. 5 times 2 times 3 could be 2 times 3 times 5. But what is important is that we have a 5 column, only 5s go here, a 2 column, and a 3 column. Let's make an extra column in case we need it. Let's break down the 42. Well, that's 7 times 6, so I'll have to put 7 in its own column. And then 6 is not a prime, so I'll break that down. That's 2 times 3. I already have a 2 column. I already have a 3 column. And then we bring down each of our unique factors. multiply them together. So the smallest number that 30 goes into and 42 goes into is 210. Let's play the missing factor game. So what's 30 missing? Well, there's a missing factor in this column, which is a 7 column. So that's what's missing. 7 times 30 is 210. What's missing from 42? Well, there's a missing factor in this column, which is a 5 column. So 5 is the missing factor. And remember, we're going to use these missing factors when we're adding fractions with different denominators. These are the numbers we'll use to build up the fractions. All right, sometimes the easiest problems seem harder, so let's do this one. 5 is already a prime, so it can't be broken down. If we make a chart, it just gets its own column. And 7 is already a prime, so it cannot be broken down. So the least common multiple of 5 and 7 is just 5 times 7, or 35. All right, let's do another. All right, let's challenge ourselves by finding the least common multiple of 12, 16, and 9. So that's the smallest number that 12, 16, and 9 all divide evenly. And this would be a good time to hit that pause button and try it on your own. All right, so if you want the most efficient way, you're going to put only prime numbers in this chart. So 12 is 2 times 2 times 3. And remember, it doesn't matter what order you put those numbers, but what does matter is once you have them, they each get their own column. 16 is 4 times 4, but you need to break those down. So that's going to be 2 times 2. We'll skip this one. Times 2 times 2. And then 9 is 3 times 3. So I'll put the first 3 in its own column. And the other 3 needs a new column. So the least common multiple of 12, 16, and 19 is going to be 2 times 2 times 3 times 2 times 2 times 3, which is 144. All right, let's play the missing factor game. Now it's a little more challenging because there's more than one missing factor. So what's 12 missing? It's missing 2 times 2 times 3, which is 12. And 12 times 12 is 144. What's 16 missing? Well, it's missing a number in the 3 column and the other 3 column. So it's missing 3 times 3, which is 9. 9 times 16 is 144. What's 9 missing? It's missing a factor in these 4 columns. So it's missing a 2, a 2, 2, a 2, 2 times 2 times 2 times 2, 16. All right, so why did we want to find the LCM? So that we can add fractions with different denominators. So the first step in adding fractions with different denominators is to find the least common multiple of all the denominators. So the least common multiple of all the denominators is called the least common denominator, or LCD. And most math people use LCM and LCD interchangeably, and that's totally fine. So we take the 2 denominators and put it in the chart and do the prime factorization. So this would be a good point to hit pause and practice on your own. So 14 is 2 times 7. And 21 is 7 times 3. So the least common multiple of all the denominators, or the LCD, is going to be 42. Let's play the missing factor game. What's 14 missing? Well, it's missing a 3. What's 21 missing? It's missing a 2. We're going to use this in the next step. So the next step is called build up the fractions. We're going to multiply each fraction by a fraction that is equal to 1. And remember, a fraction that's equal to 1 is a fraction where the numerator and the denominator are the same number. And the reason we do that is so that they'll have the same denominator. So I'm just going to write down our original problem. They have different denominators. We want them to have the same denominator, and that new denominator is going to be the least common denominator, which is the least common multiple of all the denominators. So I have 14, and I want 42. And that's where we can use the missing factor game. So I have 14. I want 42. What do I multiply by? 3. But remember, it has to be a fraction that's equal to 1, because 1 times any number is the same number. So I'm not changing the fraction, I'm making an equivalent fraction. Same thing here. I have 21. I want 42. I'm going to multiply by the missing factor. But I don't just multiply the denominator. I want to multiply the numerator and the denominator by the same number, because then I'm multiplying by 1 and I have the same fraction, or an equivalent fraction. So 3 over 14 is equivalent to 9 over 42. 13 over 21 is equivalent to 26 over 42. And you might be tempted to reduce at this point, but if you reduce, you'll be back at the beginning. So only reduce at the very end. All right, now that the denominators are the same, we can simply add the numerators. So we get 9 and 26 make 35. And remember that the denominators stay the same. And anytime your answer is a fraction, you want to check and see if it can be reduced. So reduce if possible. So 35 is 5 times 7. 42 is 6 times 7. 7 over 7 is equal to 1. And the answer is 5 over 6. Let's do another one. All right, let's add 7 over 10 and 7 over 15. And this will be a good place to pause and try it on your own. All right, so the first step is to find the least common multiple of all the denominators, which is called the least common denominator. So the numerators just go along for the ride at this point. Remember, put the prime factors in your chart. So you can find the smallest number that 10 and 15 go into. And that's 30. So 30 is going to be my new denominator. And if you want, you can play the missing factor game. So 10 is missing a factor here. 3 times 10 is 30. 15 is missing a factor in the 2 column. So 2 times 15 is 30. We're going to use these missing factors in the second step, which is called build up the fractions. So I'm just going to rewrite the original problem. Remember, we cannot add these the way they are because they have different denominators. So we're going to multiply by a fraction that's equal to 1, and that's crucial. Remember, you want to multiply by a fraction where the numerator and the denominator are the same number, and that way you're multiplying by 1. And anything times 1, it's the same number. So I have 10. I want 30. So I'm going to multiply by 3 over 3. Bring this down. I have 15. I want 30. So I'm going to multiply by 2. But remember, it has to be 2 over 2 because that's equal to 1. So when you build up fractions, you're making equivalent fractions. So 7 times 3 is 21 over 30. 7 times 2 is 14 over 30. Then we add the numerators. The denominators stay the same. And then always check and see if your fraction can be reduced. And it can. That's 5 times 7. This is 5 times 6. 5 over 5 equals 1. And your answer is 7 over 6. And you might be freaking out because the numerator is bigger. We'll talk about that in the next section. But for now, you can just leave it like that. All right, let's try another example. 9 over 16 plus 7 over 12 plus 1 over 48. And like before, this would be a good place to hit the pause button and try it on your own. All right, so the first thing you want to do is find the least common denominator. So you take all your denominators and write the prime factorization. So 16 is 4 times 4, or 2 times 2 times 2 times 2. Twelve is 2 times 2 times 3. And 48 is 2 times 2 times 2 times 2 times 3. Let's play the missing factor game. What's 16 missing? What's missing? A 3. What's 12 missing? 2 times 2, or 4. What's 48 missing? Well, it's not missing anything. So we can use this in the second step, which is to build up the fractions. So I'm just going to rewrite the original problem. Just so we don't get lost. So, oops. So I have 16. I want 48. So I'm going to multiply by 3 over 3. Remember, you always multiply the numerator and the denominator by the same number. I have 12. I want 48. So I'm going to multiply by 4 over 4. I have 48 and I want 48, so I don't have to do anything to this one. 9 times 3 is 27 over 48. 7 times 4 is 28 over 48. We get 1 over 48. And remember, you may be tempted to reduce at this point, but if you reduce here before you've added, you'll be back at your original problem. So you always reduce at the very end. So we add the numerators. 28 plus 27 plus 1 makes 56. And now we can reduce. And it doesn't matter how you break them down, as long as you keep going until they cannot reduce any longer. Eight over 8 is equal to 1. And your final answer is 7 over 6. So just keep reducing until you cannot reduce anymore.